What is going on, everyone? Today we are diving into the world of artificial intelligence, and I'll be sharing the top 5 tools or languages you need to learn to kickstart your AI journey. Now, whether you're a beginner or looking to level up your skills, these languages are a must-have in your toolkit. So let's get started. Now, the first tool we will be talking about is Python. Now, Python is a high-level general-purpose programming language known for its readability and simplicity. AI development often involves complex algorithms and data manipulations, where Python's syntax shine by making code more understandable and maintainable. Now, Python is also a very versatile language that supports both object-oriented and procedural programming paradigms. Python is the language of choice for a wide range of AI applications, from machine learning and deep learning to natural language processing. Now, the NumPy and Pandas, there are two essential Python libraries widely used in data science and artificial intelligence projects for numerical operations, array handling, and data manipulation. Now, first we'll talk about NumPy. Now, NumPy, short for numerical Python, provides support for large multi-dimensional arrays and matrices, along with mathematical functions to operate on these arrays efficiently. Now, here are some key features and examples of NumPy in Python. So in order to show you how we use NumPy in Python for machine learning, I'm going to show you an example of how NumPy works. So the first thing I'm going to do here in Python is I'm going to import NumPy as np, and I'm going to create an array first, which is going to be my one-dimensional array basically. And I'm going to do this using NumPy, and I'm going to hold some numbers here. And now what I want to do is I want to print this array. And let's see what it does for me. Let's see. So as we can see, it printed our first array. Now I can also use this concept of NumPy to build matrices, and I'm going to show you in this video how we do that. So first, I'm going to build my first matrix. So I do the same thing, numpy.array, and then I have this bracket, and then my first matrix, and then my second matrix, which is gonna be 3, 4. So this is my first matrix right here. So after this, I can build my second matrix, which is gonna be same thing, and then the brackets, and then I can do 3, 4, and then 5, 6 here. So as you can see, we have like 2 of our matrices now. So I can actually go ahead and even multiply these matrices using NumPy. So the way I do is I go for product and p dot dot. I can put my first matrix, and then I can put my second matrix here. So, and now I want to print this product, and let's see what NumPy does for us. And as you can see, it gave us the solution and it printed product. So this is how you basically use NumPy, and this is just some understanding of the NumPy in Python. Now, another concept I want to show you, which is commonly used in machine learning and data science using Python, is Pandas. So Pandas essentially is built on top of NumPy, and it provides high-level data structures like series and data frame. So I'm also going to show you how we use Pandas in the data science and Python for machine learning. So let's first again import Pandas in Python as PD, and this is how you import Pandas. And now I'm going to define a data, like some of my data, because I don't have a file here. So I'll just go ahead and like establish some data. So let's go ahead and give it name, and then this is going to be my name. I have Alice, I have Bob, just a moment. Okay, and then I have Charlie. Okay, so these are the names I have. And now the second thing I want to do is I want to give it like age variable, and this is how I define the age, which is going to be one of my parameters. And then I'm going to give all these 3 an age. So let's give 25, 30, and 35. And the third variable I want to give here is their salaries. and let's give it salaries 50,000 suppose, and then I can give 60,000, and then I can give 70,000, and our bracket is closed. So essentially this is our data. We have name, age, and salary of these three individuals. And now I'm going to show you how we create data frame, which is done using pandas. So I'm going to call it df, which is data frame, pd.data, and then frame, and then I give this data to it, which I put like on the top. And now I want to go ahead and print this df, and let's see what it gives us. So as we can see, we have our data frame built using pandas. Now there is much more I can do with this data frame. So for example, if I want to go ahead and select a column, I can actually go like this: ages is equal to data frame, and then I can select age here, which is one of my variables, and this will help me to select my column. Or what I can also do is I can actually go ahead and filter like the highest salary. So how I do this using pandas and data frame is I'm gonna go for high salary is equal to, and then the data frame, and then I'm gonna select data frame again, and then what I want to do is I'm gonna select the variable salary, and then suppose I wanted like more than a certain value, I could give it like a value of suppose more than 60,000. So as we can see, we have this here. So now like let's see if it prints it for us. So I want to go ahead and print high under secure salary. So let's see what it does. So as we can see, it prints the highest salary for us, which is for Charlie, which is more than 60,000. So this is one thing we can do. Or we can also use pandas in Python for data analysis and data description. So for example, what you want to do is you want to describe your data. So by using pandas, how we do that, you just go ahead and print, and then it's as simple as just df.describe, and now like just print this, and it's going to describe your data. Like as you can see, it's giving you all the variables: count, mean, average, max, which is like a very powerful tool again. Now as you can see from these examples, both NumPy and pandas, they offer pre-built functions and methods that accelerate the development process in AI projects. The vectorized operations in NumPy and powerful Panda allow developers to focus on high-level tasks such as model building and evaluation, rather than spending time on low-level implementations. Now without wasting any time, let's move to our second tool, which is essential to learn AI. So the second thing you really need to be familiar with is the deep learning frameworks, which play a crucial role in developing neural networks such as image recognition, natural language processing, and more. So these deep learning networks, they have an abstraction layer which allow developers to define and train complex neural networks without dealing with low-level details. Now these frameworks, they can handle like large-scale neural networks by accelerating hardware acceleration, making it feasible to train deep models on powerful GPUs. And they're also very flexible in designing architectures, allowing researchers to experiment with novel network structures. So the two examples of these deep learning frameworks, they're like TensorFlow and Pytorch, again, which we use in Python. So TensorFlow, it's known for its scalability, making it suitable for large-scale training. And the Pytorch, it uses dynamic computation graphs, which makes it more intuitive for debugging and experimentation. The use cases of Pytorch, they could be like research and prototyping, and the use case for TensorFlow, they could be industrial applications or production level deployment. But let me show you how we can go ahead and install and run these on Python. So now for the demonstration of TensorFlow and Pytorch, I have my Python notebook open again, and I'm going to show you. So the first thing I'm going to do is I'm going to import TensorFlow in Python. So I import it as TF. And now from TensorFlow, I'm going to get Keras. Now Keras is also used to build neural networks, and it's important to like import. So I'm going to import layers and the models from there. So just a moment. So let me run all this first. So as we can see, we already ran this. So now the first thing I'm going to do is I'm going to define a model in order to build the neural network. So how we build a model is I'm going to write model equal models dot sequential, and I give like the parameter, and now I want my layers, right? So just a moment. Sorry, it just auto prints. So I'm gonna open the bracket, and so let's just write. So I'm gonna like start defining my layers here. So the first, I wanna flatten my layer. This is gonna transform the input data into the size I want. So let's give it input shape of, I want to give it a shape of 28 by 28, and this is essentially my data dimension, my array input array dimension, and I'm gonna add a comma here, and then I wanna also go ahead and dense the layer because you need to define the neurons. So let me dense it 128 duration is equal to array. Okay, now what I want to do further is I want to dense the output layer with 10 neurons. So again, I'm going to use the dense function and 10 comma activation equals softmax. Now softmax is one of our activation functions. So now this is how the way I set up like my model, right? So I want to make sure I can get out of here and run this. Okay, so let me see why it's giving me. Oh, I didn't have a bracket here. So let me see. Just a moment. So looks like has no attribute flatten. Okay, I misspelled it. Okay, so we should be all good. So now the third thing I want to do is I want to compile my model, right? So the way I compile my model is I'm gonna go model.compile, and I want to use an optimizer. Now my optimizer, it's gonna be Adam. Use these ones just in case, and then I want to give it a loss, and let me give this a loss of sparse categorical cross entropy. Okay, and now I want to give the matrix as accuracy. Now I can open the bracket and give this. So this is how I compile my model layer, and I'm again gonna run this just to make sure there are no errors, and this looks good. And the final step is to train the model. So this is how I'm gonna fit my model, model.fit. And I'm gonna give it training images, then I want to give it training labels, and then I want to use epochs, and epochs necessarily means like how long I want to train the model for. So in this case I want to do 10 seconds. So again, I'm back on my Python notebook, and I already have the Scikit Learn or Scikit Learn example opened here for you. And this is one example of a machine learning project you could try with the Scikit Learn or Scikit Learn in Python. So essentially what it involves, we use historical data, and we fit the data, and then we predict it, and we then evaluate the model and give it an accuracy score. And Scikit Learn, like in this way, we actually use the Scikit Learn to like build our machine learning project. But let me explain it for you. So the first thing you do is you import Scikit Learn. From Scikit Learn, you import some data sets, because we want to use like the original data sets based in the Python libraries in order to test our machine learning model. And after you import data sets, you are gonna run a model selection, and you're gonna split your data basically in a training data and testing data. And in the third step, from sklearn.neighbors, you import a classifier which you're going to use to evaluate our data. And then the fourth process, in the fourth step, we need to import accuracy score, so we can give our data an accuracy score, right? So now for this example, we use iris dataset. So in the iris dataset, we first import the data and the target, and we give it X and Y. And now you're gonna split the data into training and testing data. So in this case, you can see I have X train, X test, Y train, Y test. And then I split it and I give it test size of 0.2, and I put the random state as 42. And after I'm able to split my data, I'm gonna go ahead and use a neighbors classifier, and I'm gonna give it like the neighbor 3. And after that, I'm gonna fit my data, and the way I fit it, I use the dot fit function, and I give the X train and Y train model to the fitting data. And then I'm gonna predict it using dot predict, and finally I give it the accuracy score. So I have some error here, but let me just clearly fix it. Name access not defined. That's because I didn't run my data, but this is just to show you the example of how you can use Scikit Learn in order to run a machine learning models. Yeah, so I'm able to fix it now. Now the fourth tool you need to be really good at is our Jupyter Notebook and Google Colab. Now for this purpose, I was already working in the Google Colab, but this already have an imported Jupyter Notebook which runs on their cloud, and it's an interactive development environment. It provides you a flexible platform. And you can use its editor, its terminal for deployment, and you can run your code here, and it have like rich set of features, and it is a very powerful tool for machine learning and data science projects. So I would definitely recommend you to test Google Colab and Jupyter Notebook. Now some of the benefits of these are you can collaborate in real time with other users. You can comment here, which is pretty easy, like this one, #describe your data. And then it's always running on the latest version, and it's integrated with Google Drive, so your work is always saved. So this is something I really recommend to you, and it's pretty easy. Like, this is my notebook here, and you can insert code here, you can insert headings through here, you can run the data, you can import libraries. So I would definitely advise to check its functionality. Now finally, I would definitely advise you to check out Kaggle. Now Kaggle is important for several reasons. It's a platform that brings together a global community of data scientists, machine learning engineers, and researchers. So it's going to provide you a space for collaboration and knowledge sharing. Now second reason is competitions. Kaggle hosts data science competitions where you can participate and showcase your skills by solving real world problems. Now another important reason, which is for me the most important, is Kaggle offers various datasets and kernels that allows you to practice and improve your data science and machine learning skills. So if you're someone looking to learn machine learning and data science, it's going to be a very valuable resource for both you as a beginner and even if you're experienced, for someone like me. Now the fourth reason is networking, because Kaggle's going to provide you a platform to connect with like-minded professionals in the field of data science. Now furthermore, Kaggle also provides you an integrated environment. They also have a built-in Jupyter Notebook and access to GPUs, which is going to really help you to work on real-time projects. And finally, Kaggle promotes open data, by hosting data sets that are freely available for analysis. So again, it's going to be a big plus for collaboration and development of innovative solutions to various challenges. So overall, Kaggle plays a crucial role in advancing the field of data science by providing you a platform for learning, collaboration, and the practical application of skills. So that was all for this video. I hope this video really helps you understand the tools required to learn data science, machine learning, and artificial intelligence. If you guys face any questions, just let me know in the comments. And if you enjoyed the video, please like, share, and subscribe. Until then, see you next time.